Hi, it's Barney here from PBE Projects, the Quality and Inspection Refractory Services Company. I'm going to talk today about maintenance strategies, and some of you may have seen the previous revision of this video. Let's see if you can find out what I changed. A maintenance strategy involves the identification, resourcing, and execution of repairs, replacement, and inspection decisions. And there we go. This is what I did. I added some photos. A typical maintenance strategy. Well, there are six. Preventative, predictive, reliability, reactive, total productive, and risk-based. Yes, you may have a different name for one or the other of them, but in the generic term, that is roughly what they are called. So factors that help determine a strategy are age, history, criticality, operation impact on assets, cost of asset consumables. And then I decided to add this as well. Consumable assets are assets which through use over a short period of time became obsolete, worn out, or otherwise became in need of being replaced. So preventative maintenance, it's the proactive approach. The goal is to get the most out of the equipment in terms of lifetime and production while preventing untimely breakdowns. It's scheduled and often linked to an automated software system that loads work orders. It involves periodically taking assets offline and inspecting or repairing them at predetermined intervals for a predetermined period. The challenge may often be in the ability to assess the probable failure mode accurately, given potential failure was avoided. Poor judgment could lead to a premature breakdown, though, and reactive maintenance requirements. An issue may be to identify the correct anticipated scope of work for leading up to the preventative maintenance and not neglecting or fixing something prematurely or not at all. Often, an inspection may be discretion-based and hopefully professional. Optimizing the strategy by reviewing history, data, trends, and so forth is referred to as failure mode effect analysis. Predictive maintenance or condition-based maintenance. The goal, it aims to predict failures before they happen so maintenance can occur at just the right time. Thanks to advancements in technology, it presents an opportunity for cost saving when compared to preventative maintenance. The reliance on document data and sensor information means maintenance is determined by the actual condition of equipment. Industry 4.0 and the industrial Internet of Things is making it increasingly easier to predict scenarios. The use of thermal imaging, vibration sensors, in-service endoscopy, drone technology, borescopes, and laser scanning. These are just some of the things that makes life a little bit easier. Of course, relying so heavily on data means that there is higher upfront costs to ensuring this maintenance approach can thrive. Another thing to keep in mind with predictive maintenance is that you have to walk before you can run. For an organization coming from a pen and paper or Excel-based maintenance program, you have to first build on the processes and insights that preventative maintenance provides in order to build an effective predictive maintenance plan. Reliability maintenance. The goal? Create a customized strategy on the basis that failure is not generic or linear. Equipment does not perform or fail to the same rate or at the same rate or for the same reasons. A good reliability-centered plan is generally based on successful preventative maintenance strategies, which evolved to successful predictive maintenance strategies, affording one a reliable strategy. The odds of a reliable system of equipment is maximized because every little detail is analyzed. So reactive, corrective or breakdown maintenance also referred to. The goal? Fix things when they break and be prepared for troubleshooting, adjustment, repairs or replacement. Justification could be based on the cost of shutting down versus the impact on the bigger picture on operations. The criticality to operations is typically low. Total cost of safe making for maintenance repairs are typically high. And typically for low priority and low cost equipment, this is where you'd find your reactive maintenance strategy typically implemented. The result of failure would not be catastrophic to production, and when it fails, it can be considered time to fix or assume full return of its value in terms of its time it rendered in service. This is obviously with relation to the reactive strategy. So reactive maintenance can mean more downtime and higher maintenance costs when it's not used strategically. Total productive maintenance, TPM. The goal? Maintenance embedded into everyday operations. It's a strategy that operates according to the idea that everyone in a facility should participate in maintenance rather than just the maintenance team. It's seen as the process of using machines, equipment, employees, and supporting processes to maintain and improve the integrity of production and the quality of the systems. Risk-based maintenance. The goal? It addresses risk-sensitive systems and machinery. It determines the most economical way to distribute resources in order to repair a system or minimize risks. There we go. That's the long and the short of it. I really made it brief, and thankful to many of these references, I could share some of this information with you. So, at the end of the day, quality is not an accident, it is intentional. The correct strategy for your refractory maintenance should really consider all the variables. Well, if I say all the variables, it's within reason. In any event, maybe we can help you with your strategy. Let us know. Let's see where this takes us. Thank you for your time. I really appreciate it. It was, it's not as easy as it sounds to make these videos. Sometimes I've got to do it like 5 or 7 times because I stutter or I skip or something happens. In any effect, I'm just human. We all are at the end of the day. And yes, fortunately, I've got an amazing team that backs me up, and that helps a lot. Good. That's my story. Talk to you soon. Cheers.